Today we're going to discuss hypothesis testing using Excel. All images from this presentation are taken from the Untitled Chapter presentation. All problems in this book or in this presentation are found in this book, Modern Business Statistics with Microsoft Excel, and of course we're going to use Microsoft Excel for the computation. As an overview, these are the steps in hypothesis testing. So step 1, you state the null hypothesis and the alternative hypothesis. Step 2, you choose the level of significance. Step 3, select the appropriate test statistic and establish the critical region. Step 4, collect the data and compute the value of the test statistic from the sample data. And step 5, make the decision. So, as with your estimation of parameters, we have two types of hypothesis tests. The first one are the tests used for population mean, and the second one is the test used for population proportion. So let's start with the test used for population mean. The following conditions are needed to use the following test statistics. So for the first condition, the sigma or the population standard deviation is known regardless of your n. We use this test statistic. Z is equal to x bar minus mu all over sigma divided by the square root of n. Condition 2, your population's standard deviation is unknown and your sample size is less than or equal to 30. So instead of z, we use your t table. So t is now equal to mean minus mu or sample mean minus population mean divided by sample standard deviation divided by the square root of n. And lastly, we have your sigma or your population standard deviation is unknown but your n is greater than 30. We use z is equal to x bar minus mu all over s divided by the square root of n. And as a review, we also have the following critical region. So if it's a one-tailed test, we only look at one of the tails. So if it's less than, we look at the negative z alpha or negative t alpha. And if it's greater than, we look at positive z alpha or positive t alpha. Of course, if it's a two-tailed test, we look at negative z alpha over 2 and positive z alpha over 2, negative t alpha over 2, and positive t alpha over 2. So let's go to the problems. Problem 1. Consider the following hypothesis test. Null hypothesis is population mean is greater than or equal to 80. Alternative hypothesis is mean is less than 80. So that's step 1. Identify your null hypothesis and alternative hypothesis. A sample of 100 is used. The population standard deviation is 12. Compute the p-value and state your conclusion for each of the following sample results. Use alpha equals 0.01. So this is now your level of significance. So we now choose your test statistic. So for the test statistic, since the population standard deviation is known and the sample is 100 and this is less than, so we use your first test statistic because the sigma is known. And our critical region is now z less than negative z alpha. Okay, so the alpha to use is 0.01. So looking at our z table of value, we look at what is equivalent to 0.01. So 0.01. 0.01 negative 2.33 negative 2.33 oh 0.01 negative 2.33. So this is now negative 2.33. Then we simply input the other test values. So let's solve for A. The mean is equal to 78.5. So the sample mean is 78.5. The population mean is 80. Your population standard deviation is 12 and the sample size is 100. Okay, so that's from the problem. The sample of 100 is used to the sample size. The population standard deviation is 12. Your use alpha equals 0.01. The alternative hypothesis, the hypothesis is that the mean is less than 80. So this is now our values, which actually corresponds to this equation or to this statistic. So first we use your mean, sample mean minus population mean. So this is now equal to 78 minus 80. Then next is sigma divided by the square root of n. So we get the square root of your sample size. And that's sigma divided by the square root of n, or 10. And then lastly, you have your negative 1.5 divided by 1.2, which is equal to negative 1.25. So z alpha is equal to negative 1.25. Z value is equal to negative 1.25. And our critical region z should be less than negative 2.33 for us to reject the null hypothesis. But then negative 1.25, which is your z value, is actually greater than negative 2.33, which is our negative z alpha value. So since negative 1.25 is greater than negative 2.33, so we do not reject the null hypothesis. Okay, so that's your conclusion. So and since we're asked to compute the p-value, you can also look at the z table of values, and the p-value is equal to negative 2.33 or negative 0.90099, that's 0.01. And then in this computation, negative 1.25. So let's look at the value for negative 1.25. Okay, so the value for negative 1.25, this is 0, 1, 2, 3, 4, 5, is 0.1056. So that's this 0.1056. Okay. And since 0.1056 is greater than 0.01, so we do not also reject the null hypothesis. Okay, so we only reject the null hypothesis if your p-value is less than alpha, or if your z value is less than your computed z value is less than your alpha z alpha equivalent. Okay? So that's for less than. Okay, then let's also check greater than. Okay, since there is a given here that's greater than 80, so let's also compute for x bar is equal to 81, since 77 and 75.5 are also less than 78.5. Let's compute for this one 81, which will now still with this alternative hypothesis that the population mean is less than 80. So let's use 81. So 81. So for 81, still that's your sample mean minus your population mean. Then we also have your population standard deviation divided by the square root of your sample size. Then we have sample mean minus population mean divided by your sigma divided by the square root of n. So this is now 0.833, and 0.833 is obviously greater than negative 2.33, 0.833, and 0.833 is greater than negative 2.33. So again, you do not reject the null hypothesis. You do not reject the null hypothesis. So your conclusion is that your population mean is actually greater than 80. Since you're not. Now let's proceed to problem 2. So consider the following hypothesis test. The null hypothesis is that the population is less than or equal to 12. So our alternative hypothesis is that your mu is greater than 12. A sample of 25 provided a sample mean is equal to 14 and a sample standard deviation S is equal to 4.32. So compute the value of the test statistic. There is a recommendation. There is a recommended t-distribution table here to compute the range for the p-value, but we're going to use the table that we used for estimation of parameters. At alpha equals to 0.05, what is your conclusion and what is the rejection rule using the critical value and what is your conclusion? So let's analyze this problem. So first, the alternative hypothesis is that your population mean is greater than 12 and a population standard deviation is unknown. The population standard deviation is unknown and the sample is less than 30. Okay? So we're going to use the second test statistic, which is sigma unknown n is less than or equal to 30, so this is now equal to x bar minus mean all over s divided by the square root of n. And our HA is mu is greater than mu 0 and our critical region is now T is greater than T alpha. The alpha is 0.05. Okay, then ang ating degrees of freedom is n minus 1. Our sample size is 25. So the degrees of freedom is 24. The sample standard deviation is 4.32. The sample mean is 14 and the population mean is 12. Sample mean is 14, population mean is 12. The sample standard deviation is 4.32. And let's look at your T table. The degrees of freedom this is a one-tailed critical value at 0.05. The degrees of freedom is 24. Okay, so 24. Okay, n minus 1. And the value for 0.05 at 24 is 1.711. 1.711. So our t value is 1.711. So now let's compute for the t value. This is the t value. Okay? So the t value is sample minus mean. So this is sample minus mean. Then S over square root of n. So S is your sample standard deviation divided by the square root of n, which wala tayong compute. Okay. So the square root of n is equal to the square root of 25, which is 5. Okay. So this is now 4.32 divide 5. Okay, so that's 0.864. Then you'll have x or sample mean minus population mean divided by standard deviation divided by the square root of n. So this is now 2.31314. And your critical region is T is greater than T alpha. So since 2.31481 is greater than 1.711, we reject the null hypothesis since our computed t value is greater than our t alpha value. Okay? So reject the null hypothesis. We reject the null hypothesis and say that the population mean is greater than 12. population mean is greater than 12. And now let's proceed to problem 3. So consider the following hypothesis test. The null hypothesis is equal to mu is equal to 100. And our null alternative hypothesis is that the mean is not equal to 100. A sample of 65 is used. Identify the p-value and state your conclusion for each of the following sample results. Use alpha equals 0.05. The first one is the mean is equal to 103 and the sample standard deviation is 11.5. Okay? So, to analyze this problem, this is a two-tailed test. The population standard deviation is unknown. A sample of 65, which is greater than 30, is used. So we are going to use test 3. Test 3. And we're going to use z alpha over 2. So the alpha given is 0.05. And since this is z, so 0.05 divided by 2. That's 0.025. And so this is now equal to 1.96. Or at least your z alpha over 2 is now equal to 1.96. 1.96. Yeah, 0.025. Okay. So let's start with the first one. The mean is equal to 103. Population mean is equal to 100. The sample standard deviation for the first problem is 11.5. And the sample size is 65. Okay? So, since this is z alpha over 2, so we reject the null hypothesis if the absolute value of z is greater than z alpha over 2, or the absolute value of your computed z is greater than 1.96. Okay, so let's have the square root of 65. Then to compute for the z value, we use this test statistic. So mean minus population mean. Then we have sample standard deviation divided by the square root of n. Then for z value, or computed z value, this is now equal to 3 divided by 1.43. So this is now 2.103, which is actually greater than 1.96. Okay, so 2.103 is greater than 1.96. So we reject the null hypothesis. We reject the null hypothesis since the computed value is greater than our z alpha over 2. Okay, is greater than our z alpha over 2, which is 1.96. So 2.1 is greater than 1.96. So for the first problem, we reject the null hypothesis and say that the mean is not equal to 100. Okay? The mean is not equal to 100. Okay? So let's also try problem B. X is equal to, sample mean is equal to 96.5 and sample standard deviation is equal to 11. Okay? So this is now 96.5 and this is now 11. And the rest is as is. So we have sample mean minus population mean, and then we have sample standard deviation divided by the square root of your n. Then you divide the 2. So this is now negative 2.56. And the absolute value of negative 2.56 is 2.56. Okay? Or negative 2.56 is actually less than negative 1.96. Okay. So still, we reject the null hypothesis. We reject the null hypothesis since this is less than negative 1.96. Diba? So absolute value of z alpha over 2. So reject the null hypothesis and say that your population mean is not equal to 100. Population mean is not equal to 100. Okay? So these are the possible values for your test or hypothesis testing using for population mean. So for population mean. And test used for population proportion. So there is only one test. So your HO or your null hypothesis is that your population proportion is equal to your sample proportion. The test statistic is equal to Z is equal to P minus population proportion divided by the square root of population proportion times Q sub 0, where Q is equal to 1 minus P sub 0 divided by N. Your alternative hypothesis are the following three. It will be less than, greater than, or not equal to. And the critical region are still as follows. It could be less than, greater than, and absolute value of Z. So this is the critical region. Okay. So we reject HO if Z is less than negative Z alpha. We reject HO if Z is greater than Z alpha. And we reject HO if the absolute value of Z is greater than Z alpha over 2. So let's go to the problem. Consider the following hypothesis. Your P is equal to, or the hypothesis is, the null hypothesis is that your population proportion is equal to 0.20. Your null alternative hypothesis is that your P is not equal to 0.20. A sample of 400 provided a sample proportion P bar is equal to 0.175. Compute the value of the test statistic. What is the P value at alpha equals 0.05? What is your conclusion? And what is the rejection rule using the critical value? And what is your conclusion? Okay. So let's plot this one, the sample proportion. So the sample proportion is 0.175. The population proportion is 0.20. So the Q value is equal to 1 minus their population proportion. And the sample size is 400. The alpha to be used is 0.05. Okay, and since this is one-tailed test, so that's 0.05. So 0.05, 0.05. 0.05 is 1.6, 1.645. Okay. 1.645. And we compute for your Z value. So P minus P sub 0, so sample proportion minus your population proportion. Then we have here your P hat times Q hat all over N. So let's have this one. Or let's have population proportion times Q. Then this is divided by N. Divided by your N. Then you get the square root. Square root. This one. Okay. And finally, you divide your P minus your population proportion by the square root of P times U all over N. So this is now negative 1.25. Okay? And negative 1.25 is less than, no, 1.645. Negative 1.25 is greater than negative 1.645. Negative 1.25 is greater than negative 1.645. So we do not reject the null hypothesis. We do not reject the null hypothesis. Okay? Since your z is greater than your computed z is greater than your z alpha. Okay? So we do not reject the null hypothesis and conclude that the true proportion from the sample is not equal to 0.20. Oh wait. Oh, z alpha over 2 because it's 1.96. 1.96. Okay. Still, this is negative 1.96. So negative 1.25 is greater than negative 1.96. My bad. Two-tailed testing. Two-tailed test. Okay. So negative 1.25 is greater than negative 1.96. So we do not reject the null hypothesis. Then problem 4. The U.S. Bureau of Labor Statistics reports that 11.3% of U.S. workers belong to unions. The BLS website, January 2014. Suppose a sample of 400 U.S. workers is collected in 2014 to determine whether union efforts to organize have increased union membership. Formulate the hypothesis that can be used to determine whether union membership increased in 2014. So, di ba, increased. So, greater than? So, that's greater than. Z is greater than Z alpha. If the sample results show that 52 of the workers belong to unions, what is the p-value for your hypothesis test? And an alpha 0.05, what is your conclusion? Okay, so let's copy this whole thing. So, the sample proportion now, so ang ating test is Z as greater than Z alpha. So, since it's Z alpha, so the value earlier is 1.645. Okay, so greater than, so 1.645. Then the sample proportion is 52 belong to union. So this is now 52 divide 400 for the sample proportion. And for the population or sample proportion, 11.3%. So that's 0.113. Okay. So the Q value is now equal to 1 minus 0.11. 1 minus 0.113. So the sample size is 400. Our alpha is 0.05. So since one-tailed test, so we use 1.645. So that's this one. So for the Z value, that's still sample mean minus population, sample proportion minus population proportion. Then we have population proportion times Q. Then we divide this by the sample size. And then we get the square root. The square root. And then, okay, so you get the square root of your p sub 0 times q sub 0 divided by n. Then let's divide your sample mean minus population proportion by this one. So this is now 1.07, which is not greater than your Z alpha. Okay? So 1.07 is less than 1.645. So we also do not reject the null hypothesis. Okay? Because we will only reject the null hypothesis if your Z is greater than your Z alpha. But our Z alpha is 1.645 and our computed Z is 1.07. So we do not reject the null hypothesis. Okay? So let's go check. Okay? Since the hypothesis, the formulated hypothesis can be used to determine whether union membership increased in 2014. Okay, so increased, so meaning it's greater than the population proportion. Okay, but since our results show that it's not, so we we do not reject the null hypothesis. So still, 11.3% of U.S. workers belong to unions, less than or equal to, hindi greater than. Okay, and that ends the presentation for the hypothesis testing. So if you have any questions, send me a message